Hi, welcome to the TypeScript Tidbits for JS Dev series. In each video, we'll discover some cool stuff about TypeScript in just 5 minutes or less. Before exploring TypeScript, first we're gonna have to unlearn a few old habits in JavaScript. So in this video, we're gonna do just that and look at better alternatives that apply to both modern JS and TypeScript. Let's get started. One of the main features of JavaScript is type conversion, or implicit type conversion, making it possible to mix numbers and strings in expressions like this. The problem with this syntax is it's not immediately clear, especially to someone new to JavaScript, whether 1 plus 2 is evaluated as an arithmetic operation or as a concatenation. And it's quite easy to end up in a bug, like what we have in here. Of course, we can use parentheses to fix the precedence like this. Here we have the plus operator used as both concatenation and arithmetic addition in the same expression. But there's a better and clearer way to do this, by using template literal. The backticks clearly mark the entire expression as a string, while the sub-expression inside the curly braces with dollar prefix can be of any type, and is evaluated independently before it gets interpolated into the string. In fact, even if we're not dealing with numbers at all, this syntax still proves to be quite convenient. And as a bonus, it even allows us to use single and double quotes in our string without the need to escape them. In the old days of JS, when global variables were common and modules didn't exist yet, developers needed to check for undeclared globals this way. And because this also effectively checks for declared but still undefined variables, it became a habit among JS developers to check for undefined this way. But nowadays, we normally don't use globals anymore, and our linters check for undeclared variables. So we only need to check if the value of a variable is undefined. JS has the core concept of truthy and falsy. Because of it, any variable regardless of data type can be coerced into a boolean when used in conditions. The cost of that flexibility is that it makes the intention of the condition a bit ambiguous. For example, in this code, did we just mean to check if count is undefined or also if it's 0? Since what we actually meant was to check if count has no value at all, rewriting it this way is much clearer and gives us our expected result. It's important to be specific with what you're testing against instead of truthy or falsy. The truthy-falsy concept has blurred the distinction between different ways to represent non-existing data. It made it okay for a function to return something like this or this. However, returning false should only be okay if the function is really boolean, and returning undefined doesn't make an awful lot of sense. What we should be returning in this example is actually null, which is the proper value that represents non-existing data. When working with data objects in JS, especially those with nested properties, it's been quite common to use the logical AND operator in some guard condition like this. But in modern JS as well as in TypeScript, we can write it more concisely like this. This is called optional chaining. The dot prefix with question mark works similar to the regular dot operator, but it checks for null or undefined value to the left of that operator. Whenever null or undefined is encountered at any level in the nested properties, it would short-circuit and the entire expression evaluates to undefined. Let's take a closer look. You see, when the first part of the optional chain is evaluated, the operator sees that data is undefined. So the entire expression short-circuits, meaning it stops right there and immediately returns undefined. Traditionally in JS, this is how we set a fallback or default in case our variable has no value. In this example, the logical OR operator returns an empty object when data is falsy. But it's not any falsy value that we want to test against, is it? Now there's a better and clearer way to do this. This is called knowledge coalescing. It works similar to logical OR, but it only checks more specifically against null or undefined. It's also fairly common to use this in combination with optional chaining, like in this example. Here, instead of the short-circuit value of undefined, we set a default value of null. And that concludes our unlearning video. Now we can start with the learning part coming up in the next videos.